Hi, everyone. This is Frank from TargetedTechTalk.com. Today is episode 10. We're going to be discussing LoRa radio, including a lab demonstration of the radio technology. So, what is LoRa? LoRa stands for long range radio. So, it's used for off grid communication. So it does not use a traditional Wi-Fi kind of setup. It does not use a cell phone signal. It's not Bluetooth. It is kind of its own radio communication system. So it can be used for off-grid communication and different purposes. It's also useful to understand this technology in the context of other types of radio communication. So kind of going into this in some detail gives us a good background about how other systems might work and function. So we're going to be talking about LoRa radio. We're going to be talking about specifications and details. So some of the frequencies and some of the limitations. We're going to take a look at the parts list. I'm going to go through a working demo. So I've got a lab setup and a video demo I recorded of exactly kind of a home setup of a LoRa radio communication system, and then wrap it up with a little bit of analysis on what we learned, through this through the process of experimenting with LoRa radio and figuring out everything. Okay, so LoRa radio, long range radio system. It is for low powered wireless communication. So the range we're talking about here, in kind of an urban situation, high population density, a lot of signals, we might be looking at between 2 and 5 kilometer range here. So definitely a lot further than a traditional, kind of Wi-Fi setup or that kind of thing. If you're thinking about a small antenna, this is really, it is a low powered system, so it's not going to go a massive distance, but it can go, 10 kilometers or more in rural areas if you have a decent antenna. Um, so that kind of gives you some context for the range of this kind of system. So LoRa itself does not include encryption, but you can encrypt it through software. So the clients that connect or use LoRa can utilize encryption. So it can be part of that communication. You can run it through an encryption layer. So LoRa itself has different applications. You can kind of think about Internet of Things. So potential applications could be farming, industrial application, anything with sensors or wireless communication. LoRa is basically an open frequency. So we'll talk about the details on some of the upcoming slides here. But to utilize LoRa communication, it does not require a subscription or any sort of special license. So you don't pay anyone for LoRa. It's kind of a peer-to-peer radio communication system. You can kind of set up like LoRa servers if you have a network of sensors or something like that. So you can kind of think about that. So it also does not require any sort of special license, at least in the North America that I'm talking about. You can use LoRa in other regions, so it is not specific to the US. It is a global thing. I'll give some of the frequencies, I think, for North America and Europe. There's other specific frequencies for different locations, so it is a worldwide thing. Just kind of check your region for the specific frequency that you should be using. But it does not require any special licenses, so you don't need a ham radio license. You don't need anything special. It's basically an open peer-to-peer frequency, and it's a reserved frequency for this use, so you don't have to worry about running into other types of signals, or turning this on and interfering with other things. it's a dedicated LoRa signal, basically. So that's a little bit about LoRa radio. In terms of communication here, you can kind of think about this as primarily it's data. It can be used for um, kind of compressed voice communication, but primarily it's data. So any kind of device that needs to communicate with another device. So Internet of Things, in a farming application, you might have different sensors, moisture sensors, sunlight sensors, um, motion sensors. We did you can kind of think about some of the previous demos we did as part of this series, like the ultrasound um, rangefinder. You could connect that to a LoRa network, and then when something gets within range, you could fire off a signal to something else that turns on a light or logs it to a database or does something else. So really, the possibilities are pretty wide open. You can kind of think about Internet of Things as basically anything that can have a little antenna and a LoRa transceiver can participate in this. So it can be specialized sensors, industrial applications. You could have things tracking statuses of devices and kind of tracking, parts and locations and status and things like that. Okay, so some of the specifications here. So again, this is going to be something you're going to want to check your region for. In the US, it's going to be 915 megahertz. In Europe, I think they actually have two different bands. The most common band is 433 megahertz. And then if you're outside of those regions, you can just kind of look up what the LoRa band is for your area if you're going to be setting up a device. So, for example, with the demo, there's source code out there, and you have to put in the frequency that your system is going to use. So you're going to want to make sure that if you're in Europe, you use the Europe frequency. If you're in the US, you use the US frequency, and so forth. If you kind of mix them up, then you could be broadcasting on a band that's reserved for something else in that region, and that could get you in trouble. So just kind of be careful of that detail. But if you kind of stick to the band that's been defined for your area, it's open for use, so there's no restrictions. Anyone can use LoRa. So it is relatively low bandwidth. So the transceiver that I'm using for this demo, they recommend up to about 19.2K. I think the spec can go up to 26K. So if you have a higher powered transceiver, a little more advanced stuff, you can go a little bit further, but kind of set your expectations for relatively low bandwidth. You're not going to get, kind of streaming movie level stuff here by any means. So primarily it can be used for data. So it can be used for texting. It can be used for voice communication with some compression. It can be used for system-to-system communication with data. The Internet of Things kind of applications you might think about. So the parts list for my demo here, I'm going to be utilizing this Adafruit transceiver. So what a transceiver is it means that it can both transmit and receive. So the chip, I think, supports a couple bands. The US band is 915, so that's what we'll be using there. And then if you want to reproduce this lab on your own, this is the complete parts list. In order to communicate, you need basically 2 copies of everything. So you need 2 transceivers, 2 Unos, and 2 breadboards in order to complete the setup. Otherwise, you can just kind of look at the demo I did and kind of get the details there. I did not have to write any source code or the wiring diagram this time. The vendor for this particular LoRa transceiver that I got did a pretty good job of doing a wiring diagram for Arduino, as well as some of the source code for a transmitter and receiver. The one thing about LoRa that I would note if you're doing other projects, you do want to be careful to kind of check the reviews of the LoRa transceiver that you're going to be um, purchasing, and be careful of the voltage as well. There's a lot of kind of low priced LoRa transceivers out there that are kind of junky, and I'm not going to name the transceiver I got for the first time, but I picked a transceiver that was a little bit lower price, and ran into some issues with it. I was not able to complete the first version of my project. I did go with this Adafruit transceiver, which is, I do recommend this one if you're doing anything with Arduino or similar microcontroller. But that is some of the limitations or some of the things to be aware of if you're going to be doing LoRa on your own. Number one, pay attention to the reviews of the device. I think I had one that was like half size pins, so the soldering on that was very challenging. The other um, device I tried was low power, so that's a thing. You have to be very careful with the low power transceivers when using it with a higher power device like the Arduino Uno. If you make wiring mistakes or mistakes with the pin, that can damage the lower transceiver. The Adafruit transceiver that I recommend here, there's really no issues like that. It supports up to the 5 volts control. But just kind of in general, if you're going to be doing lower projects on your own, those are the two gotchas I would put out there. Just kind of be careful of the product reviews if you pick up your own, and then be careful of the low voltage situation. So, like a low voltage transceiver could work a lot better with a different microcontroller, like an ESP32 would work better with a 3.3 volt transceiver, for example. But this Adafruit one is 5 up to 5 volts, so I think it supports 3.3 and 5. So this was a good choice if you're going to be using Arduino Uno. Highly recommend. So from there, we will go ahead and jump into the demo video, which is going to go through kind of my lab demo, a complete end to end for the LoRa radio setup here. All right, so this is a quick lab demonstration of LoRa radio. So I've got two Arduino Unos in my lab setup here. So I've got a receiver unit here, which is connected to my PC, which we'll kind of see the output and see the details from. And then we've got the Arduino Uno, and then the connections to the breadboard with the LoRa transceiver there, little antenna attached. And then we've got the transmitter unit, which I have previously loaded up with the LoRa transmitter program that we're going to be taking a demo of here. So this is a fairly short range test, really just kind of a lab environment here to demonstrate the concept. LoRa itself can go for much longer range, as we'll cover in the presentation, but this is just basically a working end-to-end. So I've got two Arduino Unos, two of the Adafruit LoRa transceivers. So each unit is a transceiver, so transmit and receive with the breadboard connection to the microcontroller there. So I've got the Arduino Uno or the Arduino IDE loaded up on my PC. So we can see the output there. So when I power on the transmitter to the right, then the receiver to the left is going to pick up that details, and we're going to be able to see the output here on the screen. So that's going to be the setup here. So let me go ahead and power on the transmitter. There we go. So we've got power connected there. And if we check serial monitor on the Arduino IDE. Now we're seeing the details start to come through. Hello world, 1, 2. I can even clear the log here so that we can see fresh data coming in. So it's just doing a hello world and then adding a count to that. So we can see everything basically here working end to end. We've got the transmitter unit and then the receiver unit using the LoRa radio connection between the two. All right, so that was the demo. Um, Final analysis here. So LoRa, I think, is pretty valuable in itself. Any kind of project that you're looking to do on your own, where you might be looking for an alternative to Wi-Fi or something with a longer range. Um, this could be a useful application, Internet of Things. If you have some projects where if you have a kind of a shed or an outbuilding and it's kind of outside the range of Wi-Fi. You don't want to run any special cables, but you might want to have some kind of sensor out there or some kind of project. This would be something good, as well as kind of regional communication. So you can kind of do texting and you can do some compressed voice communication using this technology. And it would be, basically completely off the grid. So um, there's no Wi-Fi it goes through. There's no cell phone network it goes through. There's no subscriptions. There's no license requirements. It's basically, you know, basically LoRa itself and the free airwaves. So, if you have other people within that 2 to 5 kilometer range, or up to 10 in the country, you can. There's even sort of some networking thing where you can kind of extend it beyond that. Kind of share that network with your group and communicate amongst yourselves. Or kind of coordinating things or different kinds of applications there. So Internet of Things, basically any project you want to do, this LoRa technology can be valuable. Just kind of keep in mind the limitations and the expectations here that it's not a super high bandwidth. Um, it is free and none of those restrictions, but the bandwidth is limited. So you're probably not going to use this for a streaming movie server or something like that. It's going to be um, more along the lines of sensors or texting and some limited voice communication, that kind of thing. So this is useful to understand this technology in and of itself. And this is also going to be similar to other communication technologies out there, is based upon some of the principles that we demonstrated. So some things to think about here, um, something LoRa or something like LoRa, there is other restricted bands that could be used in a similar fashion. Um, if somebody's, you're thinking about dedicated communication systems, that military might use or emergency services might use or other, government parties might use. It's all going to, fall under this, a similar pattern. So understanding LoRa helps us understand some of these other radio frequency communications. So some of the things to keep in mind would be something like this or a different band that's dedicated, could be used for a management network. So what is a management network? If you think about a given system, you might use a system as a user, but there could be a separate communication network, and there often is, for the management and configuration of those devices. So you see this very commonly in a corporate environment. You see this in systems all the time. So, for example, you might consider a cell phone network. You use a cell phone as a user, but the company running those transceivers, those antenna, that cell phone location, they don't need to use cellular signals to manage it. It could be managed off of a separate network, controlled off of that. So that's the concept. If you haven't done any advanced networking or security, you might not be familiar with that, but just kind of introduce that concept. So there is management networks separate from the use of those devices. So, for example, a management network for an antenna system, cell phone tower, something like that. The management network could use something like LoRa as a backup. It could use, often they'll use a hardwired, fiber connection or something like that. Whereas users might go through the cell tower, a management network might go through, a fiber connection that way. But you could kind of think of alternatives that LoRa could be used for those management networks. And so, for any given device. So kind of think about that, and maybe not LoRa per se, but this a similar method of this technology. Other RF, other bands that might be higher bandwidth, that might be part of those reserve bands. Somebody could set up a system like the LoRa demo that we did, using those other bands, using high bandwidth, longer range technology, and it would be all off the grid, right? So if you um, consider the case of cellular networks, again, if you're kind of going forward with the hypothesis that everything is on the cellular network, you would be incorrect. It could be something like this, issuing commands to that cell phone network, the management network, or if it's a specific device like a cell phone network, or there's actually different providers and different antennas within a cell phone system. You could kind of think of what about a management network? What if that management network is off grid like this and there's no record of that activity? So if you're counting on everything for a cell tower being cellular, you might want to re-examine um, some of those hypotheses there, that actually there could be other things. And this technology kind of points the way that understanding this technology is good, and understanding some of the things we've covered in these demos is good, because that tells us what is possible. Um, a related example would be, we talked about Proton VPN being a logless system. So it doesn't matter how many lawyers you have, you can contact them 5 times, 10 times, 100 times, they will never have the logs. So understanding how the technology works helps set the direction for other things. So it's good to have a good foundation of how you understand technology and what's possible. So here we kind of dug into LoRa specifically, but it is a good use case of this RF technology and gives us some insights about how encrypted off-grid communication could be used in other contexts. Similarly, if you find someone that appears to be talking on their cell phone, don't assume that it's a cell phone, for example. So if it's, they could be, it's certainly possible to use a technology, to use LoRa specifically, or a technology similar to that, to communicate wirelessly using a device with that form factor. And you kind of saw the LoRa transceiver was about as big as a quarter, and that's a big transceiver for LoRa. You can get smaller ones that are low powered, that are half or less that size. So it is a long range technology like that supports kind of a smaller form factor. So if you see someone talking on a cell phone, what appears to be a cell phone, don't assume that it is definitely a cell phone and you can get their cell phone records, for example. It could be encrypted off-grid communication like this, in which case the log uh, exists if they want to give it to you, or if they choose to not keep a log, there's nothing to be found. The only the only indication would be that temporary use of the bandwidth. If it was LoRa, it would be 915 in the U.S. Other areas, different frequencies. So that's pretty helpful to understand the context and provide a good foundation for RF communication just from this one kind of simple demo. So if you're interested in LoRa, the transceiver that I used is one that I highly recommend for lab projects, especially if you're going to be doing anything with Uno. For sure, I would use that if you're going to be doing a smaller microcontroller or kind of other devices. I would keep in mind too that if you're going to be doing something like a sensor, you're probably going to need something at least at the microcontroller level to run the LoRa software, because you can't just plug in the transceiver into power and it works. It's The transceiver sends and receives the data, but it's working at the direction of the software on the microcontroller. So you don't necessarily need a full PC or computer, like a Raspberry Pi is a full computer, and something Arduino is a microcontroller, so it's a layer down, and you can get the ESP32 would be another smaller one. Um, so you can get smaller form factor microcontrollers, but you would need something. You couldn't just plug in a transceiver into power and expect it to work. It's not all on the chip. You need at least a microcontroller to drive that. So that's kind of a good roundup and analysis. So thanks for watching today's presentation, and we'll see you next time.